Hello friends, today we will discuss about twisting operation in simplex. Till now we have discussed objects of simplex, and in that we have discussed that there are three main objects of simplex: drafting, twisting and winding. So we have studied some facts about the drafting in we have already discussed some facts about the drafting in simplex. So today we will study the twisting operation in simplex. So why twisting is necessary in simplex? So twisting is generally done to impart strength in the roving or yarn. In textiles, twisting is applied to increase the strength. In simplex, it is applied to the roving, and in ring frame, it is applied to the yarn. In TFO or doubler, it is applied to the plied yarn. So twisting can be of various types. It may be true twist, it may be false twist, it may be self twist. So in simplex and ring frame, it is true twist. So true twist remains forever. If you apply in the yarn or roving, it will remain in the material. False twist means whatever we are applying, that may disappear later on. And self twist is a different technology, that is applying alternate Z and S twist in the material. So that is not related to this simplex. So twist is applied to increase the strength in the roving. In textiles, the strength is also improved with the help of adhesives, that by the addition of polyvinyl alcohol fibers. And there is one Twilo process also that you will study next year in another subject. So at present, only two terms are relevant, that is true twist and false twist in simplex machine. So today we will study only these two parameters, true twist and false twist in simplex. So first of all, what is the need of twist in simplex? If we will not apply twist in the roving, then it will not have sufficient strength, and we will not be able to wind the roving on the bobbin, and it will not be possible to transport the material from simplex to the ring frame. So for this, some minimum strength should be there in the roving, so that it can be easily transported to the ring frame, next machine. And suppose if we are applying high twist in the roving, then what will happen? If the twist in the roving is very high, then also it will create problem in ring frame, and spinning will not be possible, and undrafted problem in ring frame will come. In this undrafted problem, roving will come out as it is from drafting system of ring frame, and yarn formation will not be there. So if the roving of high twist is formed, that creates a great problem, and sometimes it is not possible to reduce the twist, and the material becomes waste. So some twist is necessary. so that the material can be transported to the next machine ring frame. And a very definite and calculated amount of twist, or you can say minimum twist, is required so that it should have, roving is having sufficient strength. So the formula of the twist per inch is spindle speed divided by front roll delivery. So twist is applied when the material from the front roller is coming out and spindle is rotating, and on the spindle flyer is there, and flyer is rotating at a high speed. So due to revolution of the flyer and spindle, the twist in the roving is inserted. That is the material between front roller nip and flyer top. So this material gets twist. So twist is expressed in different forms. It may be twist per inch. It may be twist per centimeter also. It may be twist per meter also. So as you will choose the unit, the same unit will be for the twist. If you are expressing the front roller delivery in centimeter, then it will be twist per centimeter. If it is the unit of pi dn is in meters, then twist per meter will be the final unit. So twisting is applied in the simplex as we are feeding sliver in the simplex. After drafting, the material comes in the form of ribbon of fibers, and a very fine fibers are coming. So with the revolution of the spindle, the material gets twisted in the zone which is between front roller nip and flyer top. So in this zone, material get twisted and roving is formed, which is wound on the bobbin. And when this bobbin fills up, this bobbin is taken out after doffing and then taken to the ring frame and fed on the ring frame so that yarn formation takes place. So if the twist is protective twist means the twist which is just sufficient to protect the roving, and so that easy transportation can be there. So for real twist, we are using the formula this spindle speed upon front roll delivery, and false twist is also inserted in the zone between front roller nip and flyer top. On the flyer top, there is a insert of rubber which is having grooves, notches or indentations. So when the spindle is revolving at a very high speed, so the roving gets some additional false twist due to rolling down of the roving over the grooves of the false twister. So the material is rolling down, and due to rolling down, some compactness in the material comes, in the roving comes, and it makes the roving compact. So this false twister is used in the simplex, and it is put up on the top of the flyer, and care should be taken that false twister should have same number of grooves or notches throughout the simplex. For the same lot, the number of grooves in the false twister should be same throughout the simplex. Sometimes the grooves are different, so that may create problem, because that will ultimately put the difference in the twist also. So we should take care that false twister of same kind, same number of grooves should be used on the one simplex. So after that, we will study now winding material on the bobbin. So for winding the roving, both spindle and bobbin should rotate. Why? Why spindle and bobbin should rotate? Because if suppose flyer is stationary, why we are moving the flyer? Because if flyer will not be moving, twisting in the roving will not be possible. So if flyer is stationary, no twist in roving is possible. So it is necessary to move the flyer. Actually, we are studying that why there is a need of revolving flyer and bobbin also, or package. Why there is need? Is there any possibility that only flyer should move or only bobbin should move? And why there should be difference in the speed? So today we are studying the two cases. Suppose if flyer is stationary, then twist will not be possible in the roving. So that's why it is necessary to move the spindle, and ultimately flyer will also be moving because flyer is mounted on the spindle. Then if package is stationary, then simplex will run. But in that case, only one turn per wrap will be possible. Actually, we require, as I have told, that twist, sufficient twist or protective twist should be inserted, and it is generally coming out to be 1 TPI. 1 TPI means you can say approximately 40 twist per meter are required. But if package is stationary, then only one turn per wrap will be possible, which means one twist in one circumference, one turn. Means 3.14 into 106 mm, which is package dia. It implies one twist in 333 mm, or you can also say 3 twists per meter. But actually we require approximately 40 twists per meter. So for that, we should revolve the package also. So to twist and wind the roving simultaneously, both spindle and bobbin should rotate in the same direction. So two options are available, bobbin leading and spindle leading. So we will continue this topic in the next lecture also. So today we have studied that what is the need of the twisting, and for twisting it is necessary to revolve the spindle, and flare is mounted on the spindle, so it is necessary to revolve spindle and flare so that twisting is possible. So to have sufficient twist, we should rotate both flare and this bobbin also. So what should be their speeds of the spindle and bobbin? That we will study on the next lecture. Thank you.